This time I'm going to be talking about the preparation of INCAT for anion cation jobs and excited state and the follow information. As previous speaker have already discussed, the INCAR is the most important, the crucial and central file of the VASP. It tells what job to do, and it tells kind of it's a task. So this is what I take from my own work. First, you need to count the total number of electrons. There's a couple of ways. You could just type GREP and number of electron outcar, or you could go to outcar, find, because we see there's a list of 40 states, so you could count the total number of electrons directly from there. And we need this information because normally, if the molecule we were dealing with is the titanium hydroxide, it contains 64 electrons. But if we need to run it as a anion, we need add one more electron. So we need modified our INCAR file by nano it. And this is a screenshot of a INCAR file. You can see the difference between these two is the total. We add one more code, the total number of electrons. So the next step is we need to run VASP. And after we've done that we wait until the job is done. And next we need to create the states file, as we have already discussed. It's a specific job, and we kind of specify it. And we need to make sure that the states is being modified. That's just a mistake I've made when I was doing this. And the rest is we already see these. We convert it to PDF. We show it. We make it the file that can be read by our own system. And there's a way we convert to PDF version. And the C-do excited states. I apologize that I didn't have my own experience of that. But what I know is that we need to modify the INCAR by typing these. The first NSW, we already know that we need to save some time because the file is already being optimized. And here, this is what we need to add at the end of the whole INCAR file. And the first one is the number of occupied orbital, followed by a hole and one more occupied orbital, then followed by the LUMO, the number of unoccupied orbitals. So what does this information tell us? As this theory states, the anion is a model which the population of LUMO is increased. The cation is a model which the population of HOMO is decreased. So a anion means there's a one additional electron in the LUMO state, which specifically is seeing the 33, out of the all 40 states, and the cation is the one less electron in the HOMO, which is the 32. So as Professor told us, if we can, for example, if the total energy of the anion is all the states added up, if we use the total energy of neutron minus the total energy of anion, it's going to be giving us a total energy of the LUMO state. So this is the screenshot I took from this TI48 anion. This additional part gives us tells us that there's one additional electron in the after the gap This is the LUMO part. And this is the cation, which contains one last electron. All right, that's it.
Okay, let's send Beijing.